Hello everyone. Um, my name is Papri Ghosh. I'm assistant professor in CC Data Science Department. So today we are going to study about stack. So first, what is stack? First, we are going to discuss about stack and how to implement it, and then some problem of stack. Then we are going to continue in another session. First, we have to know what is stack. So stack is a linear data structure. In a linear data structure, what is data structure? First, we have to know what is data structure. Data structure means it's a where we can store or organize our data. So, and what is linear data structure? Linear data structure means data structure in which data elements are arranged sequentially or linearly, where each element is attached to its previous and next adjacent elements. So, what is the example of linear data structure? Linear data structure example like array, stack, queue, linked list. So there are mm, other data structure like static data structure, dynamic data structure. I want to discuss about static data structure, dynamic data structure, because static data structure has fixed memory size. It is easier to access the elements in static data structure, which is uh, the example of static data structure is array. And what is dynamic data structure? Dynamic data structure, the size of the size is not fixed. It can be randomly updated during the runtime, uh, which is maybe considered efficient concerning the memory complexity of the code. Memory complexity means space complexity. Example queue, stack, and what is nonlinear data structure? Nonlinear data structure means data structure where the data elements are not placed sequentially linear. So now I'm just giving some. We are assuming that we all know about array, but I'm just uh, quickly revise the matter. What is array? Array is linear data structure that stores a collection of elements of the same data type, and the elements are allocated contiguous memory. That means each element has a unique index number. So now we are coming to this. What is stack? Stack is a linear data structure that follows the last in first out rules. What is the meaning of last in first out? Last in first out means, let's assume we have a pile of disk. Okay, I can show it here. Mm, okay, so when we are going to store the CDs, first we are going to keep like this. This is a pile of disk. So when we are going to access the last disk, then we have to remove this disk first, then this, then this. That if it is 1, if it is 2, if it is 3, then first we have to remove 1, then 2, then 3, then we can access the fourth C. That means which which are entering first, one which are in last position, that disk is going to out first, right? So that is last in first out rule. And you can say it also philo. Philo means first in last out. Okay, so in a stack, both the addition and removal, that means when we are going to insert an element and when we are going to delete any element, that will be from one end, not both end. Okay, here when we are going to insert any element, it is called push operation, and when we are going to delete an element or remove any element, that is called pop operation. So push operation and pop operation of elements are performed from one end. And there is a pointer which are going to point the topmost element, that is called top of stack. Okay, so here LIFO means last element added is the first to be removed, and the first element is added is the last to be removed. So the last element added is the first to be removed means LIFO, and the first element added is the last to be removed mean filo. They're same. The principle is the same. So the top element is the most frequently accessible. Okay, and while the element is at the bottom is the least accessible. Now there are some conditions. So what kind of conditions? This is stack. So at first top will be pointed here. At first top will be pointed here. There are no elements. Stack is empty, right? Stack is empty. That means the value of top, top is pointing the first element. So now stack is empty. The value of top will be -1. Okay, that means when top equal to -1, it means that the stack is on the floor. When we are going to insert any element like 5, okay, then top will be +1. Top equal to top +1. So top equal to, so the last value of top is -1, and we have inserted 5 in stack. So now the value of top will be top +1, and -1 +1, that will be 0. So 0, and this is the top, right? Okay. Now, Slack implementation. Stack is generally implemented in two ways. One is static, and other one is dynamic. So, what is static? Static implementation means we are using an array to create an stack, and it is a simple straightforward method to but lacks flexibility. And the size of stack must be defined during design. That means we have to define the size of stack before running program. Okay, like here there are 1 minute, like 1 2 3 4. The size of stack is 4. The size of stack is 4. Okay, so this is the 0th location, 1 2 3. Okay, that means we can store 4 elements in the stack. Okay, and what is dynamic implementation? Dynamic implementation means we can uh, we, uh, we can store any, we don't define the size of stack, don't define the size of stack. We can store any, we can store okay. So dynamic implementation, also known as linked list implementation. So here top, again here top will be will indicate the first most element. topmost element, sorry, top will indicate the topmost element. Okay, so when we are using linked list, first top will keep the topmost element. Here you can we are showing that one is we are going to store one. So first we have taken in a blank node, we have stored one in the data part, and the next part where we are storing the address of next node, it will be none. Then we are going to insert 2, right? Then we have taken a node, blank node, where we have kept the value 2, and the address part of that node 2 are storing the address of 1, or we can store the address of top, the value of top, right? And now top is showing the top is indicating the 2. That means topmost element is now 2. Same for 3 also. So we all know about the push operation and pop operation. Push operation means inserting an element, and pop operation means deleting an element, right? So first, here is a problem. First, we are discussing the push operation or pop operation. Then we are going to discuss that problem. So push operation. The what is push operation? The process of adding new element to the top of stack is called push operation. The new element will be inserted at the top. After every push operation, the top is incremented by 1, and in the case array is full, then it is called overflow condition. And if the array that means the size, if the size of array is n and the value of top is n or n minus 1, then it is called overflow condition. N and n minus 1 is differ because when we are starting the index from 0, then the size, let assume we have shown an array, the size of the array is 6, right? So we are starting the index from 0, so that means the top of the if the we have kept the all values in that array, 0th position, 1st position, 2th position, 3rd position, 2nd position, 3rd position, 4th position, 5th position, then the value of top will be 5. That means n minus 1. If the index starts from 1, then the here it will be 6 instead of 5. Okay. So what is the overflow condition? Overflow condition, if the array is full and no new element can be inserted, that is called overflow condition. So push s in top comma x. What is s? S is here is stack. N is the size of stack. Top is the topmost element. And the top is top is a pointer which are pointing to the topmost element, and x is the element. Okay. So now if top equal to n minus 1, that means top equal to the, that means the array is full, print stack overflow. Otherwise, top equal to top plus 1, is of top equal to x, and exit. Okay, so I have discussed with an example. Now we are going to pop operation. Okay, first there is a problem. Which of the following is true about linked list implementation of stack? In a push operation, if new nodes are inserted at the beginning of linked list, then in pop operation node must be removed from end. In push operation, if new nodes are inserted at the end, then in pop operation nodes must be removed from the beginning. Both of the above, none of the above. We have discussed before that inserting an element and insertion of an element and deletion of an element will be from one end, not both end. Okay, when we are inserting new end from the beginning, if new nodes are inserted at the beginning of linked list, that means pop operation will be start from the beginning, right? Here we are following the rules LIFO, last in, first out. Okay. So in push operation, if new nodes are inserted at the end, then the pop operation must be removed from the beginning. That means none of the above. Okay. Is that clear to you? Now come to the pop operation. The process of deleting an element from the top of stack is called pop operation. After every pop operation, stack is decremented by 1, then there is no element in the stack and the pop operation is requested. This will result to a stack into a stack under full condition. So let's assume we have a stack. So top will point here, right? Now uh, if top equal to -1, then print underflow, then and exit, or y equal to s of top, top equal to top -1, return y and exit. So now s of top let's it is 0 position, 1th position, 2th position, 2nd position, sorry, 3rd position. Okay. So now what is the value of top? The value of top is 3, right? So s of 3 is 2. Okay. Top equal to -1? No. The value of top is 3. So now s of we are printing s of top. So what is s of top? Stack of top is 2. So now we are printing 2. Right? And top will be decremented by 1. Now top is pointing here. Right? So 3 minus 2 equal, 3 minus 1 equal to 2. Now the stack of top is 3. We are printing 3. And top will be decremented by 1. There are 2 minus 1, 1. Now the value of top is 1 and top will point here. So what is the value of s top is 4. We are going to print 4 and then it will be decremented by 1. 1 minus 1, 0. Now top will point here. Now the s of top is 5. We are printing 5 and 0 minus 1, the value of top is -1. That means that is empty because we have popped off, we have deleted all elements. So now top is 0. Sorry, now the value of top is -1. Okay, so 2, 3, 4, 5. So it is a condition of the underflow. It's a condition of underflow. Okay. Now choose the correct alternatives and write the corresponding letter only. The following sequence of operation is performed on stack: push 10, push 20, pop, push 10, push 20, pop, 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 push 20, pop. Okay, push 10, push 20. Okay. So push 10, then push 20. Now pop, push 10, push 20. Pop, push 10, push 20. Pop, then push 10 and push 20. Okay. Now pop, 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 push 20, pop. Triple pop and push 20, pop. Pop, pop, pop. And last, push 20, pop. Push 20 and pop. Okay, that means 20, 20, 10, 10, 20. So it will be the option B. Okay, it will be the option B.